received some sources this week highlighting a technology that sounds, well, less like bleeding-edge research and more like pure science fiction.
It really does. The numbers are just staggering.
Right. So let's just start with a challenge for you, for anyone listening. Try to imagine a computational problem that's so vast, so incredibly complex, that it would take the world's current fastest supercomputer over 10,000 years to solve.
An impossible amount of time, basically.
Exactly. Now hold that thought, because here's the breakthrough. A new type of machine, a quantum computer, it solved that exact same problem.
And not in 10,000 years.
Not even close. It did it in a matter of mere minutes.
Yeah.
Okay, let's unpack this.
It's probably the most dramatic technological comparison I've ever seen. This isn't just, a slightly faster chip. It's a completely different way of thinking about computation.
A foundational shift.
It is. And that gap, the 10,000 years versus, 200 seconds, that is the very definition of the global competition we're diving into today. The race for quantum primacy.
So our mission for this deep dive is to really distill this for you. We want to understand what quantum primacy actually means.
Right.
And explain how a gap that massive is even possible. But most importantly, why this leap is set to decide the future of, well, everything. Power, money, and your personal security.
And this isn't some far-off 2050 kind of threat. The implications of this are shaping decisions right now.
That's the key part. So let's start with that speed gap. That's the aha moment.
It is. A classical supercomputer at its heart is just a very, very powerful calculator. It works with bit zeros and ones.
On or off.
On or off. It checks possibilities one after the other just incredibly quickly. But these quantum machines, they aren't just a faster version of that.
They're built on a different principle entirely. They use qubits.
Exactly. They use qubits. And this is where the physics gets a little strange, but also really cool. The speed comes from two main ideas: superposition and entanglement.
Okay, so give us the quick analogy for someone trying to wrap their head around this.
The best one is a spinning coin. A classical bit is the coin after it's landed. It's either heads, a 1, or tails, a 0.
Got it.
A qubit, because of superposition, is like the coin while it's still spinning. It's heads and tails at the same time. It can be in multiple states at once.
So it's not just solving problems one by one.
It's exploring all the possibilities in parallel. If you link up, say, 50 qubits, you're not doing 50 calculations. You're doing 2 to the power of 50 calculations all at the same time.
That's an astronomical number.
It is. And then you add the second piece, which is entanglement.
This is the part that Einstein called spooky action at a distance.
That's the one. Imagine those 50 spinning coins are all magically linked. The moment one